So in this earlier exercise, in our first example of arrays, I created an array A, which is 5 ints, and then down here, I used 5 assignment statements to set it to its initial value. Now, we know already that we can use a loop, so here's an example we had in the previous video. I could use a loop to set all of the elements of a big array if the elements can be described, if they have some pattern that could easily be condensed down into a loop. But what happens if I just want to set my array to have some sort of arbitrary initial value that can't be classified in such a way that I could make it into a loop? What do? Do I want to do this? I mean, my array has size 5, and this is a lot of stuff. And if my array had size 20, which is, I mean, that should be within reason, I should be able to create an array with 20 arbitrary values, this would be really annoying. And so it's worth talking about that there are actually other options in C for initializing an array. And so this video, I'm actually mostly just going to skim over code that's already written to talk about the different modes. The key thing to understand is that in all of these examples, the initialization that I'm using only works when you initially create the array. You are not allowed to use this notation after the array has already been created. So if you already have an array and you need to set it to contain a bunch of values, then you're stuck using those assignment statements. But when you actually create the array, when you declare the variable, there are some options. So let's go through the options. The first option is you could write this. Here's an array called U. It has 20 elements. And you do not give any further information to the compiler about what it should contain. If you do this, then as of line 20, the array U contains undefined values. Now, we know already that often if you look at undefined values, they tend to be 0, especially on our Jupyter Hub installation. But to be clear, if you attempt to use the elements of this array and assume that they are 0, that is incorrect, because the compiler just leaves whatever junk was already in the space there, because you haven't told it to do anything else. And the key rule the compiler uses, the philosophy behind a C compiler is never do work unless the programmer asked for it. And all you've asked for here is, give me an array with 20 elements, with space for 20 things. That's it. You haven't said, go clean it out. And the compiler assumes that it shouldn't go clean it out for you because that would be work. That would slow the computer down. And if you wanted to clean it out yourself, you might do that later. So to be clear, if you declare an array like this, its values are undefined. They are uninitialized. Okay, but what if we do want to initialize values? Well, the first and most friendly way of doing that is this curly bracket initializer. So these curly brackets do not mean the same thing as the curly brackets we've been working with so far. This is a very limited use of curly brackets that can only be used in this context on the same line that you declare an array. This curly bracket here, as we know, opens a scope. This one does not. This is just a way of grouping together numbers so that we can initialize an array. So here I make an array of size 5, and then I use this curly bracket initializer to assign it 5 initial values. And the compiler, if it sees this, goes into the array and then assigns all of the values into the array one index at a time. So this becomes index 0, this becomes index 1, and so on. So that's one option. That's one easy way of assigning initial values to an array. I guess I'll run this. There's some code down at the bottom that maybe will get spoiled for us. But so here we are. Here's the contents of A. Now, one interesting thing about this, if you notice, the compiler, if you create an array, needs to know how big the array is. A very common mistake at this point in the course is for people to create arrays and try and give them no size. So they write this. That is incorrect. We'll actually see what happens if I do that. So the compiler says, sorry, I need a size. How do I make an array if I don't know how many elements it contains? You can't do that. You are not allowed to make an array with no size. People often want to do that because they like the idea of being able to create an array that can grow or something. That is not possible. Every array must have a size. And when you declare an array like this, the size is fixed, so you can't change it later. We interpret that to mean that the size is part of the type of the array. So in this case, the array definitely has a size. It's 5. But it's interesting to notice that the compiler actually knows that it's redundant. I say that A has size 5, and then I give you 5 elements. And it turns out that for this limited application, you are allowed to leave out the size. But the reason is because this way you don't make a mistake. So for example, suppose you decide later to add a bunch of extra stuff to the array. Well, clearly you want this array to have size 7. You gave 7 elements in the initializer. Wouldn't it be annoying if you forgot to change this size? It was 5 and not 7. So the compiler does give you a shortcut there. If you provide an initializer, you don't have to put the size in the square brackets. Instead, the size is automatically set to be whatever number of things are in the initializer. The compiler can do you a favor there. You are, of course, still welcome to put the size in the square brackets. And if you do that, this will be the size. If I say the size is 5 and I give you 7 things to put in, the compiler just ignores the last 2 of them. It just works with the first 5. So you do have the option of writing this, but all this is doing is setting the size automatically and permanently based on the initializer. This isn't some magical way of making an array with no fixed size. So I'm going to go back to what I had a minute ago. And I would add that it's actually a really good feature to have. In general, redundancy can be very dangerous, and writing it like this means that there's a chance you make a mistake if you change only this and not this, or only this and not this. So having this left blank is actually helpful to the programmer. Okay, so we can use the curly brackets to initialize an array. We can also leave out the size and have the compiler figure that out for us. And there's a few variations on that. So what happens if we include the size and the initializer doesn't match up with that? And I think if I had a live audience, I could take a poll and see what people thought would happen here. So it would be valid, I think, if the language had said, there's an error. If you do this, I don't know what you mean, so I'm just going to complain. But actually, the C language has a remedy for this. Here I've said the array B will have 5 elements. And here's 2 elements. The compiler will interpret this to mean that you don't have any ideas for what to do with the remaining 3 elements, but you will still get an array of size 5. And unlike with our array U up above, here I am clearly trying to clean out the space and initialize it myself. Even if I'm not initializing all of it, I am initializing my array. If you ask the compiler to initialize any of the array, it'll always initialize the whole thing. So what happens here, if I have an array of size 5, so here's B, and it's an array of size 5. If I have an array of size 5 and I tell the compiler, initialize it to 1, 2, what it'll do is initialize the first element to 1, the second element to 2, and then it'll say, well, you didn't give me anything else, but you clearly do want the array to be initialized, so the compiler will automatically set the remainder to 0. Always to 0 in this case. If your initializer isn't long enough for the array, the compiler will initialize the rest of it for you, and it'll always initialize it to 0. And when you have an int array, when you have a float array, it initializes it also to 0, just the floating point version of 0. We'll see later that there are arrays of lots of other stuff, but they also get initialized to the equivalent of 0 in whatever the element type is. So this is nice, and the reason it's nice is first because you can make a long array with only a few things initialized at the beginning, but it does allow a really clever shortcut to initialize an array. So if we scroll back up, think about if this array was declared to have size 1 million. And I get down here and I forgot to initialize it. Well, if I want to initialize it to be a bunch of zeros or something, I have to go through with a loop of length 1 million. I have to loop over every element and set it to 0. No big deal, but it would require me to write a loop. So if I go down here, I can use this shortcut. So we'll get that question off the screen. Here I've made an array of size 1 million. But suppose I don't want to write a loop that sets every element to 0. But I want every element to be 0. And the key thing here is I can't expect the compiler will do that for me. This way of writing it doesn't guarantee that. I have to tell the compiler I want it initialized, or I have to initialize it myself. But because of what we just saw, I know that if I give an incomplete initializer, all of the remaining elements get initialized to 0. So one clever trick I could use is I could make my array of size 1 million and initialize just the first element to 0. The compiler is now required to initialize all of the remaining elements to 0 for me. And so it does that, which I think is really convenient. Now the comment here makes a good point. It's easy for us to get superstitious and say, oh, that's fast. This is way faster than writing a loop. And you're right, it's faster for you. You don't have to write as much code. That's great, that's convenient. But to be clear, when the compiler actually deals with this, it very likely does actually generate a loop for you. So you're not actually saving the computer any time by doing this. It's a clever trick because it saves you time. That's fantastic. We should try and save ourselves time, but there's no reason that it's better than a loop. It's just a question of whether you want to write a loop or not. And then finally, let's think about this. This is, as far as arrays go in C, a lot of languages have arrays. Java has arrays, C++ has arrays, so does Python, so does pretty much every language in existence, and many of them use the same syntax as C does. In Java, if you want to use a 2D array, you do it the same way you would in C, because Java is a descendant of C. This, however, is a question that a lot of people desperately want the answer to this question to be, oh, it's easy, you just do this. So the question is, if I hand you an array, in other words, up here I've made some array, so int q 3 by 4, and then I scroll down and I ask you the question, q was already created. What is its size? And the answer is, you have no way to know. If you want to know the size of Q, you have to keep track of the size of Q. There are clever tricks that you might find on the internet. For example, if I'm in the same function where I create Q, there are tricks that would allow me to learn certain things about its size. But we want to be careful about that. In general, if you're handed an array that already exists, somebody has to tell you how big it is. There is no general way, given an array, to know how many elements it has. Other languages don't have that limitation. Other languages, there's a way of asking, here's an array, what's its size? In C, there is no general solution to that. There are clever solutions that work in some cases, but no general one. In particular, on things like assignment 4, if you need to know the size of an array, you better hope that somebody told you. And we'll see in the next video when I want to pass arrays into functions, that means I have to tell the function, not only here's the array, but also here's how big the array is, so the function knows what to do with it. So this is something that is the bane of people's existence in this course, because they really, really want there to be some magical thing they can use that tells them the size of an array. But basically, in C, there isn't.